Hello, welcome to Chemistry Past Questions and Answer Theory 2018. Question number 3A, Roman figure 1. Draw the structure of the sixth member of alkanes. Now, hydrocarbons are broadly divided into two, which are homologous series and aliphatic hydrocarbons. The homologous series are alkanes, alkanol, and others. That is, homologous series are family of organic compounds in which each successive member differs in their molecular formula by CH2. Example is alkanes. So alkanes are unsaturated hydrocarbons with a general molecular formula CnH2n. Therefore, the first member of alkane is ethane, which is C2H4. So the structure of alkane is CH2 double bond CH2, that is ethane. Now, with propane be the third member, be the second member, butane be the third member, pentane be the fourth member, hexane, heptane the seventh member, while we have the sixth member to be the heptane. Now we have to draw the structure of the sixth member of alkanes, which is heptane. So we have C7H14 to be the molecular formula of heptane. Now the structural formula of heptane is CH3, CH2, 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 CH double bond CH2. Now let's see. Now we are asked to provide the structure of the sixth member of alkanes, but we have the hydrocarbons divided into two, which are, we have aliphatic hydrocarbons, aliphatic and aromatic hydrocarbons. Now we have the examples of aliphatic hydrocarbons to be the alkanes. We have alkanes, then we have alkynes and others. Then we have the aromatic hydrocarbons to be benzene. Aromatic hydrocarbon is benzene. Now we have the homologous series to be the alkanes and alkyne. Then the homologous series are family of organic compounds, which follows a regular repeating pattern which each successive member, a regular repeating pattern with each successive member differs. That is, the member that follows each other, they differ in their molecular formula by CH2, of which examples are alkanes. Now we have to provide the structural formula of alkanes, being one of the homologous series. Now the general molecular formula of alkanes is CnH2n, while the first member will be C2H4 by substituting the 2, that is the carbon 2, as the number of n. Here we have C2 CH2 multiplied by 2, which is the number of carbons. Then we have C2H4. So this is ethene being the first member of alkanes, while we have the propene, we have butane, we have pentene, we have hexane, then we have heptane to be the second, that is from ethene. We have second, third, fourth, fifth and sixth member respectively. So heptane is the sixth member. So heptane is the sixth member. Then we have to provide the structural formula of heptane. So heptane is equals to C7H14. So we calculated this from the general molecular formula. So the structural formula is CH3 CH2 CH2 CH2, we have CH2 CH, then we have CH2. So this is the condense structure of the heptane. Then we can have the branch structure like this. So the branch structure of heptane is given as, so we have heptane branch structure to be given below as, we have C 5 6 7, then we have double bond here, then we have our hydrogen atom to be bonded with the carbon here. So we have the hydrogen atom bonded with carbons. So this is the structure of heptane. So if you like this video, click like and subscribe for more videos. Thank you. God bless you. Hello, welcome to Waec 2018 past questions and answer theory. Question number 3A, Roman figure 2. Calculate the relative molecular mass of the sixth member of the alkanes. Now this first member of the alkanes family is ethene, while the second member is propane, butane is third member, pentane is fourth member, hexane is the fourth, while heptane is the fifth. Then we have heptane to be the sixth member of alkane family. So heptane is C7H14 being the sixth member of the alkanes family. Now the relative molecular mass of the sixth member of alkane, we can calculate it as we have the relative atomic mass of carbon to be 12, while the relative atomic mass of hydrogen is 1. Now the summation of the relative atomic mass of the number of carbon we are having present in heptane added with the relative atomic mass of the number of hydrogen we are having in the molecular mass of heptane is the relative molecular mass of heptane required. Now let's see with these simple calculations we are having here. Now we have to provide the relative molecular mass of alkane. The first member of alkane family is ethene, while the second member is propane. The third member is butane, while the fourth member is pentane. Then the fifth member is hexane, while the seventh member is heptane. So heptane, it is the sixth member of the alkene that we have to give the relative molecular mass of it. Now, being the sixth member, it is the molecular mass of heptane is equals to C7H14. Now, the relative molecular mass of C7H14, which is heptane, is unknown, but the relative atomic mass of carbon is given as 12, while hydrogen is given as 1. Now, relative molecular mass of C7H14 is given as 12, which is the relative atomic mass of carbon, multiplied by 7. That is, we have 7 numbers of carbon, then we add it with the relative atomic mass of hydrogen, that is 1, multiplied by the number of carbon and number of hydrogen we have, which is 14. So we have 12 times 17, 12 times 7 equals to 84, plus 1 times 14, which is 14. So when you add the two together, the summation of it is 98. So we have this to be the relative molecular mass of heptane, which is the sixth member of alkanes family. So if you like these videos, click like and subscribe for more videos. Thank you. God bless you. Hello, welcome to Waec 2018 past questions and answer theory 2018. Question number 3, A Roman figure 3. State the differences between cracking and reforming in the petroleum industries. With the questions above, it implies that cracking are employed in petroleum industries. Petroleum or crude oil is the natural resources from which petrol, diesels, kerosene and petrochemicals are produced through the process called fractional distillation. But reforming is also employed in petroleum industry, aimed at improving the quality of petrol. It is done by increasing the proportion of branched chain hydrocarbons which yield high octane petrol. Now to the differences between the cracking and reforming. For the cracking, this is the breaking of large molecules of petroleum fractions into smaller molecules. But reforming involves the rearrangement of atoms in molecules of petroleum fraction to obtain branched and cyclic hydrocarbons. Now the number 2 difference, we have cracking is used to increase the availability of petrol, while reforming is used to improve the quality of petrol. The number 3 difference is that we have the cracking can be done thermally or catalytically, while reforming occurs in the presence of a catalyst only. So these are the differences between the cracking and reforming. So we should know that these questions above is trying to let us know that cracking and reforming are employed in petroleum industries. So cracking are employed in petroleum industry as well as reforming. So the two of them are employed in petroleum industries. Petroleum or crude oil, that is, the petroleum is also called crude oil. It's also called crude oil. Is a natural resources. The natural resources from which we derive petrol. We have diesels. We have kerosenes, and we still have petrochemicals. Petrochemicals is also the derived units from petroleum or crude oil. Then we derive all these with a process called fractional distillation. So this is the separation techniques employed in separating the petrols, diesels, kerosene and petrochemicals from crude oil. Now to the differences between the cracking and reforming. Don't forget, we said earlier that the two are employed in petroleum industry. So the differences between cracking and reforming. So let's use this tabular form to state the differences between the cracking and reforming. So number one, for the cracking, we have, this is breaking of large molecule. So this is just as breaking large molecule of petroleum. We are breaking the large molecule of petroleum fraction into smaller molecules. So this is what we have in cracking. But reforming involves the rearrangement. This is just involve the rearrangement of the atoms in molecules. Of petroleum fraction. So the number one, that is the cracking, just involve with the what? With the breaking of large molecules of petroleum fraction into smaller molecules, while reforming involves the rearrangement of atoms, molecules of petroleum fractions. Then number two differences, we have cracking is used to increase. Cracking is just used to increase the availability. Is used to increase the availability of petrol, while the reforming is used to improve the quality. Of petrol. So reforming is just as the opposite of the cracking. It is used to improve the quality. Of petrol. And number three, we have cracking can be done thermally or catalytically. So You can carry out cracking by what? Can be done thermally, or catalytically. So you can use catalyst or thermal energy to bring about cracking. But as for the reforming occurs in the presence of a catalyst. So reforming occurs in the presence of a catalyst. So we are only using catalyst for reforming, while we can carry out cracking either thermally or catalytically. So this is just the answer to the question number 3A, Roman figure 3. If you like this video, click like and subscribe for more videos. God bless you. Hello, welcome to Waec 2018 past questions and answer theory questions. Question number 3B, Roman figure 1. Define the term entropy of neutralization. Now, what is entropy? Entropy is defined as the sum of its internal energy, U in brackets, and the work required to achieve its pressure and volume. Then we have the mathematical expression for this as capital letter H is equals to U plus PV, where P is pressure, V stands for volume of the system, and H is represented as entropy. The neutralization reaction is a reaction between acid and base to produce salt and water only. Example is when we react hydrogen tetrasulfate 6 acid with sodium hydroxide to give sodium sulfate and 2 mole of water. Now, what is entropy of neutralization? It is the amount of heat evolved during a neutralization reaction in which 1 mole of water is formed. Or you can still say that entropy of neutralization is defined as when 1 mole of hydrogen ion from an acid reacts with 1 mole of hydroxide negative ion from a base to form 1 mole of water. That is, we have entropy. Entropy is defined as the sum of its internal energy, then this internal energy is represented as capital letter U, and the work required to achieve its pressure and volume. Now, this definition is given in mathematical expression as H is equals to U plus PV. Why? Where we have our H stands for entropy, so H is used to represent the entropy, while we have U representing the internal energy. So U is used to represent the internal energy. Mine is capital letter U, used to represent internal energy, while we have P stands for pressure, and V stands for the volume. E stands for the volume. Now we have the neutralization reaction. So this is the reaction between salt and water, reaction between acid and base to produce or to give salt and water only. So example of this is when we react H2SO4, that is hydrogen tetrasulfate 6 acid, we react it with sodium hydroxide as a base. Then we have Na2SO4 sodium sulfate plus 2 mole of water. Then we should know that this equation is not balanced. Then we add 2 here to balance the equation. Then this is base, sodium hydroxide, and this is acid, hydrogen tetrasulfate 6 acid. This is the salt produced, and this is water. So the state of this one is liquid, while this one is solid. We have this one to be aqueous state, and this one is also in aqueous form. Now to the enthalpy of neutralization. So enthalpy of neutralization Hello, welcome to Waec 2018 chemistry theory, question number 3b, Roman figure 2. The question says, describe briefly how enthalpy of neutralization reaction of dilute hydrochloric acid and aqueous potassium hydroxide will be determined. This is just as the reaction between hydrochloric acid and aqueous potassium hydroxide to give potassium chloride and water. Then we are asked to determine the heat evolved during these reactions, and we cannot determine this heat evolved during the reaction of potassium hydroxide and hydrochloric acid through a balanced chemical equation. Hence, an instrument is used to determine the heat of neutralization reaction, and the instrument is calorimeter. Then the reaction between hydrochloric acid give potassium chloride and water. Then the equimolar solution of hydrochloric acid and potassium hydroxide are prepared separately. Then a known volume of the acid is placed in a calorimeter, or we call it polystyrene beaker, and the temperature recorded. The same volume of the potassium hydroxide solution at the same temperature is poured into the calorimeter, and the mixture stirred gently. Now the maximum temperature of the mixture is recorded. So we now have the heat lost in the reaction equals to the heat gain by the solution formed. So the enthalpy of neutralization, that is H, or neutralization, is equals to mass of solution multiplied by the specific capacity of water multiplied by change in temperature. Now I define calorimeter as an apparatus for measuring the heat generated or absorbed by either a chemical reaction, change of phase, or some other physical change. Now the balanced chemical equation for the reaction, that is the neutralization reaction, is this. So we have hydrochloric acid, which is HCl, react with potassium hydroxide, that is KOH. Then it gives potassium chloride, and water. Now to determine the heat of the enthalpy, that is the heat effort, that is the enthalpy of neutralization reaction, we have equimolar, the equimolar solution of hydrochloric acid and potassium hydroxide. Hydrochloric acid and potassium hydroxide are prepared separately. So we prepare the equimolar of potassium hydroxide and hydrochloric acid separately. Then a known volume of the acid, is placed. So we placed it in a calorimeter. So we place it in a calorimeter, or we call it polystyrene beaker, and the temperature is recorded. So we record the temperature. So the same volume of potassium hydroxide KOH solution, potassium hydroxide solution, at the same temperature, is poured into the calorimeter. Just as to measure the heat. So it's poured into the calorimeter, and the mixture is stirred gently. So we stir the mixture gently. So the maximum temperature of the mixture is recorded. Then consider the heat loss in the solution is equals to the heat gained by the solution. Then the enthalpy of neutralization, that is our H of neutralization, is given as mass of solution multiplied by, so the mass of solution is multiplied by specific capacity of heat, specific capacity of water times change in temperature. Then you can divide the calorimeter. So the calorimeter is apparatus. Calorimeter is apparatus used for measuring. So it is used for measuring the heat generated or absorbed by either a chemical reaction change of phase or some other physical changes So this is the definition of calorimeter. It is the apparatus used for measuring the heat generated or absorbed by either a chemical reaction, change of phase, or other physical changes. So this is just the answers to the questions asked, that is to describe briefly the how enthalpy of neutralization of reaction of dilute hydrochloric acid and aqueous potassium hydroxide could be determined. So if you like this video, click like and subscribe to our YouTube channel Tclassified.com, and you can also visit our website on Waec uni.com. Thank you. God bless you. Hello, welcome to Waec 2018 Chemistry Theory Question 3. 3C Roman Figure 1. The question says an electrochemical cell is constructed with copper and silver electrode. Then state which of the electrodes will be Roman Figure 1 anode, then Roman Figure 2 at cathode. Then 3C Roman Figure 2. We have to state the reasons for your answer in 3C Roman Figure 1. Now to the answers. We are asked for which of the copper or silver electrode will be deposited at the anode or the cathode. As for the anode, we will have copper electrode deposited at the anode. Then in figure 2, we have silver electrode deposited at the cathode. Then we have to state the reasons for our answers given above. Silver has a more positive standard electrode potential than copper. So this is just one of the reasons why we have the copper deposited at the anode, then we have the silver deposited at the electrode. Then also we still have copper is more electropositive than silver, or we say that silver is higher in the electrochemical series. So this is the reasons why we have copper deposited at the anode, then we have silver deposited at the electrode. Then let's see the answers we are having here. So we are asked for the question 3C Roman Figure 1 that we have which of the copper or silver we deposited at the anode. Then we have copper electrode for the Roman Figure 1, that is copper we deposited at the anode. So we have copper electrode. Then the Roman Figure 2, we are asked for which of the silver or copper we deposited at the cathode. Then we have silver electrode. We have silver electrode deposited at the cathode. Then 3C Roman Figure 2, we are just asked to state the reasons. So the reasons for our answer in 3C Roman Figure 1. So the reason is just that we have silver as a more positive standard, have a positive standard electrode, has a positive standard electrode potential, electrode potential than copper. So this is one of the reasons. Then we can also say that copper is more electropositive. Copper is more electropositive than silver. Or we say that silver is higher. Silver is higher in electrochemical series. Silver is higher in electrochemical series. So this is just the reasons for having the copper electrode deposited at the anode. Then we have silver electrode deposited at the cathode. That is, we have copper is more electropositive than silver, or silver is higher in electrochemical series. So if you like this video, click like and subscribe to our YouTube channel www.waec-unit.com. Thank you. God bless you. Hello, welcome to Waec Chemistry 2018 Theory. Question 3C, Roman figure 4. Write a balanced equation for the overall cell reaction, that is in electrochemical cell constructed with copper and silver. Question 3D, Roman figure 1. Name the compound formed when iron is exposed to moist air for a long period of time. Then 3D, Roman figure 2. Write a balanced chemical equation for the reaction in 3D, Roman figure 1. Roman figure 3. Name one ore of iron. Now for question number 3C, Roman figure 4, we have to write a balanced chemical equation for the overall cell reaction. That is the reaction where we use copper and silver to construct electrochemical cell. Then the balanced chemical equation is when you react coppers in solid form with silver in ionic form. Then we have copper 2 plus 2Ag, that is 2A silver in solid form. Then question 3D, Roman figure 1, we have to name the compound formed when iron is exposed to moist air. When the compound is exposed to moist air, so we are in need of oxygen there. So when oxygen combine with other elements, then that oxygen become oxides. Then the compound formed as a result of long time exposed of iron to air is hydrated iron 3 oxide. Then Roman figure 2, we have to write a balanced chemical equation for the reaction in 3D, Roman figure 1, that is when iron is exposed to moist air. We have to write the balanced chemical equation. Then the equation is when you react iron in solid form with oxygen in gaseous form, then we add water to it. Then the equation gives iron 3 oxide with water of crystallization. Then Roman figure 3, we have to name one ore of iron. As we have it, we have different iron ores. So one of the iron ore is hematite, we have magnetite, we have selenite, then we have limonite. So you can just choose one out of the ores listed above, that is the hematite, the magnetite, the selenite, and etc. So let's see with this answer. Question Roman figure, question number 3C. So we have to write a balanced chemical equation for the overall cell reaction where we construct electrochemical cell with copper and silver. So the balanced chemical equation is as follows. We have copper in solid form, then reacted with silver. The chemical symbol of silver is Ag. We have silver, then we have 2 mole of silver used here to give the product as we have copper 2 plus in aqueous form, then with silver 2Ag in solid form. So this is a balanced chemical equation for question asked in 3C Roman figure 4. Then 3D Roman figure 1, we are asked to name the compound formed when iron ore is exposed to moist air for a long time. So the compound formed when iron is exposed, when iron, that is Fe, is exposed to moist air for a long time is iron 3 oxide. So we can have it, we have iron, that is iron 3 oxide. Then this iron 3 oxide is hydrated. So we have hydrated iron 3 oxide. So this is the compound formed as a result of long time exposure of iron to air. So we have hydrated iron 3 oxide, hydrated iron 3 oxide. So that is the question asks for number 3D Roman figure 1. Then Roman figure 2, that is 3D Roman figure 2, we have to write the balanced chemical equation for the reaction in 3D Roman figure 1. That is when iron is exposed to moist air for a very long period of time. We have to give the balanced chemical equation for that. So we have iron reacted with oxygen, then with 2 mole of water, that is just as 2 times H2O. Then we have iron 3 oxide, dot x mole of water of crystallization. Then where our x is equals to 1, then to balance the equation we have 4 mole of iron reacted, then we have 3 mole of oxygen reacted with it, then we have 2 mole of water, we have 2 Fe2O3, that is iron 3 oxide dot x mole of water. Then our x is equals to 1. Then we can still have our equation as 4E plus 3O2, that is oxygen gas, plus 2H2O, that is 2 mole of water. Then it gives iron 3 oxide, that is 2Fe2O3 dot 1 mole of water. So that is the balanced chemical equation for having our iron exposed to moist air for a very long period of time. Then Roman figure 3, we are asked for the iron ore, one of the ore of iron. Then we have different ores of ions. Then the iron ores are we have hematite as one of the iron ore. Then we have magnetite as one of the iron ore, but we are just asked to name only one here, so we can just pick one out of the iron ore. So we can pick either hematite or magnetite as the iron ore being asked to give. So if you like this piece, click like and subscribe to our YouTube channel, educateafricans.com. Thank you. God bless you. Hello, welcome to Tclassified. Today I'll be answering Waec 2018 chemistry theory question 4a Roman figure 2. Write a balanced chemical equation for the reaction in 4a Roman figure 1, that is preparation of sulfur 4 oxide. Roman figure 3, state the precaution that must be taken in the preparation of the gas stated in 4a Roman figure 1. Roman figure 4, give the reasons why the precaution stated in 4a Roman figure 2 must be taken. Now to the first questions, we have to write a balanced chemical equation for the reaction in 4a Roman figure 1, that is preparation of sulfur 4 oxide. Now the balanced equation is that we have 1 mole of sodium sulfate, that is NaSO3 reacted with 2 mole of hydrochloric acid, giving 2 mole of sodium chloride plus 1 mole of water plus 1 mole of sulfur 4 oxide, which is SO2. We have to prepare. You can still use another equation that we are having 1 mole of potassium trioxosulfate, that is K2SO3, reacted with 2 mole of hydrochloric acid, giving 2 mole of potassium chloride, that is 2KCl, plus 1 mole of water plus SO2, that is the sulfur 6 oxide. We have to write the balance equation showing sulfur 4 oxide. Then Roman figure 3, we have to state the precaution that must be taken in preparation of the gas stated, that is preparation of sulfur 4 oxide. What are the precautions? Precaution is that the gas should be prepared in a vim cupboard or chamber. So the gas should be prepared in a vim cupboard or chamber. So that is the precaution to be taken in preparing sulfur 4 oxide. Then Roman figure 4, we have to give the reason why the precaution stated in 4a Roman figure 2 must be taken. The reason is that sulfur 4 oxide gas is a poisonous gas. Then it must be prepared in a film cupboard for it not to exposed to the atmosphere or mixed with air. So you must, sulfur 4 oxide is a poisonous gas, and that is why we must take the precaution of preparing this gas in a film cupboard. Now question 4a Roman figure 2, we have to write a balanced chemical equation for preparation of sulfur 4 oxide. So we have 4a Roman figure 2, we have to write a balanced chemical equation for the preparation of sulfur 4 oxide. Then we have NaSO4, let's say we have NaSO3, that is sodium sulfate, react with 2 mole of hydrochloric acid HCl, giving 2 mole of sodium chloride, 2 mole of sodium chloride plus 1 mole of water, that is H2O, plus SO2. So this is sulfur 4 oxide we have to prepare. Then we have to write the balanced chemical equation. This is just the balanced chemical equation, or we can still use potassium trioxosulfate, that is K2SO3, plus 2 mole of hydrochloric acid. Then it will also give potassium chloride, that is 2 mole. Then we have water as one of the products, 1 mole. Then we have SO2 gas, that is sulfur 4 oxide gas we have to prepare. Then 4a Roman figure 3, we are asked to state the precaution that must be taken in preparing sulfur 4 oxide. Precaution in preparing sulfur 4 oxide. The precaution is that the gas should be prepared in a film cupboard. The gas should be prepared. The gas should be prepared. The gas should be prepared in a film cupboard. The gas should be prepared in a film cupboard, or we have what is it called, film chamber. Film cupboard, or we have film chamber. So the gas will be prepared in a film cupboard. So that is the precaution to be taken when preparing sulfur 4 oxide, that is SO2. Then 4a Roman figure 4, we are asked to give the reasons why the precaution stated in 4a Roman figure 2 must be taken. The reason is that the SO4, that is the sulfur 4 oxide, SO2, is poisonous gas. Then it must be prepared in a vim cupboard for it not to mix with air. So sulfur 4 oxide, the reason is that sulfur 4 oxide, that is sulfur 4 oxide, that is SO2 prepared, SO2 is a poisonous gas, is a poisonous gas. So having sulfur 4 oxide to be poisonous gas, so it means we must prepare it in a vim cupboard for you not to mix with air. So far it is a poisonous gas. If you like this video, click like for more videos and subscribe. You can visit our YouTube channel www.educateafricans.com. Thank you. God bless you. Hello, welcome to Tclassified. I'll be answering Waec 2018 Chemistry Theory, question 4b, Roman figure 1. Says, state the Dalton's law of partial prayers. So we have to state the Dalton's law of partial prayer. Dalton's law of partial prayer states that for the mixture of gases that do not mix together or react together, the total prayer is equal to the sum of the partial prayer of individual gases that makes up the mixture. That is, we may have some gases that will not react together, so the sum of the individual gases will make up the prayer of the mixture. Then we have the mathematical expression as P total is equals to PA, where PA is used to represent a gas. Then we have PA plus PB plus PC plus PN, while we have PA, PB, PC representing the gases. Then when we add these individual gases, that is gas A, B and C, the prayer of each of these gases will make up the mixture. Okay? We make up the prayer of the mixture of the gases. Then PN is when we have more than 3, because we are giving PA, PB, PC, so we may have even PD. So up to PN is what we have. So we have the number of gases to be the PN. So the sum of individual gases, the sum of the prayers of individual gases that do not react together will make up the prayer of the mixture. Then on this, when our gas is collected over water, that is when the gas is collected over water vapor, it is likely to saturate with the water vapor. Then the mathematical expression will now be P total is equals to P gas plus P water vapor. That is the prayer of gas plus the prayer of the water vapor. Then we can calculate the prayer of our gas by making it as the subject of the formula, by subtracting P total, by subtracting P water vapor from P total. So Dalton's law of partial prayer states that for a mixture of gases, that do not react, that is, they do not mix, that do not react, the total prayer of the gas, that is the mixture, the total prayer of the mixture is equal to the sum of the partial prayer, it's equal to the sum of the partial prayer, it's equal to the sum of the partial prayer of individual gases is equal to the sum of the partial pressure of individual gases that makes up the mixture. So the total pressure of the mixture is equal to the sum of the partial pressure of individual gases that makes up the mixture. Then we can have the mathematical expression as P total, that is the total pressure, is equals to pressure of gas A plus pressure of gas B plus pressure of gas C up to the pressure of up to the Pn, that is when we have more than A, that is the gas A, gas B and gas C. So we have PA plus PB plus PC up to Pn. So that's the mathematical statement for Dalton's law of partial pressure. But when we collect the gas, that is when the gas is collected over water vapor, when the gas is collected over water vapor, then the gas is likely to saturated. The gas is likely to saturate with water vapor. Then the mathematical expression will change from the first we have here to having P total is equals to P gas, that is the pressure of the gases, plus P water vapor, that is pressure of water vapor. So we are going to have pressure of water vapor. Then this is pressure of water vapor. So you can substitute the P gas by having P total minus P water vapor. If you like this video, click like and subscribe for more videos. You can still visit our website www.educateafricans.com. Thank you. God bless you. Hello, welcome to Tclassified. I'll be answering Waec 2018 Chemistry Theory, question 4b, Roman figure 2. The volume of a sample of methane collected over water at a temperature of 12 degrees C and a pressure of 700 mm mercury was 30 centimeter cube. Calculate the volume of the dry gas at standard temperature and pressure, giving saturated vapor pressure of water at 12 degrees C is 10 millimeter mercury. Now let's solve this. So we have the volume of a sample of methane collected over water vapor. So we should know here that this gas is collected over water vapor, then it is likely to saturate with water vapor. Then from the question given above, our pressure 1 P1 is equals to 700 millimeter mercury, because we are given that the volume of a sample of methane collected over water vapor at a temperature of 12 degrees C and a pressure of 700 millimeter mercury was 30 centimeter cube. Then actually here we have to calculate the volume. That volume is volume 2, that is P2. Then it means 700 millimeter mercury is P1. Then from this first statement again, we have the volume of a sample of methane collected over water vapor at 12 degrees C. So that 12 degrees C, that is T, is going to be T1. Then we have 12 degree C. Then we have to convert this degree Celsius to Kelvin. Then we have 12 degrees C plus 273 plus 273 Kelvin. That is standard Kelvin. Then we have it equals to 285 Kelvin. So that is our T1, 285 Kelvin. Then we have from the first statement again, we have the volume to be, then they said the volume, that is our P1 is equals to, so our P1 is equals to 30 centimeter cube. Then they calculate the volume, that is P2. We have to calculate volume 2, calculate the volume of the dry gas at STP. So having the STP, it means that is we are going to use standard temperature and pressure. Then our T2 is going to be standard temperature. So T2 is equals to 273 Kelvin, while our P2 is going to be a standard pressure, which is 760 millimeter mercury. 760 millimeter mercury. Then don't forget that our pressure 1, they said it is collected over water vapor. Then it means it's not actually 700 millimeter mercury. Then we are going to subtract our P total. That is what we have from the Dalton's law of partial pressure. That is P total is equals to P gas plus P water vapor plus P water vapor. Then from here we know that to calculate the real gas pressure, that is P gas, we are going to have P gas is equals to P total minus P water vapor. Then our P total here is 700, we are given, that is 700 minus, then the pressure of that filter pressure is 10 millimeter mercury given in the question, that is 10. Then when we subtract this one, we are going to have 690 millimeter mercury. 690 millimeter mercury. That is our P1. So this is the real P1 we are having from this question. Now solution to the question to calculate V2. So we use our formula P1 V1 over T1 is equals to P2 V2 over T2. Then making V2 the subject of the formula, we are going to have, that is by applying cross multiply. Then we are trying to make V2 the subject of the formula. We are going to have P1 V1 T2 all over P2 T1. Then by substituting the formulas, we have V2 is equals to 690 millimeter mercury, that's our P1, multiplied by 30 centimeter cube, multiplied by 273 Kelvin, that is our temperature 2, 273 Kelvin, all over. Then our P2 is 760 millimeter mercury, 760 millimeter mercury. Then multiplied by our T1, which is 285 Kelvin. 285 Kelvin. Now we use millimeter mercury to cancel millimeter mercury, then Kelvin we cancel Kelvin. Then our phi2 is equals to, when we multiply 690 by 30 by 273, we are going to have 5C 56 511. We have 5C so when we multiply the numerator part of the equation, we will have 56. So we are going to have 56. So that is what we are going to have here. So we are going to have, that is when we multiply the numerator, we will have 56 511 00 centimeter cube. That is the remaining units for the numerator part, all over 216600. Then our answer, when we divide the two together, we are going to have 26.09 centimeter cube. So that is what we are asked to calculate. That is the volume 2 we are asked to calculate. So the V2 here is 26.09. If you like this video, click like and subscribe for more videos. You can still visit our YouTube channel www.educateafricans.com. Thank you. God bless you. Hello, welcome to Tclassified. I'll be answering Waec 2018 chemistry theory question 4C, Roman figure 1. Write an equation for the reaction between chlorine and water. Roman figure 2. Why does litmus paper turn red when put in resulting solution in 4C, Roman figure 1? 4C, Roman figure 1, we asked to write equation for the reaction between chlorine and water. Just equation. Then we have chlorine gas, that is Cl2, added with water, that is reacted with water, that is plus H2O. Then the product is going to be HCl plus HClO. Then we should know that the resulting solution here is acidic. That is the product form. We have HCl to be acid, then we still have HClO also to be the acid. So the two product form is acidic. Then for C, Roman figure 2, they say, why does litmus paper turn red when put in the resulting solution? Then because the solution, the resulting solution given when we react water with chlorine gas is HCl and HClO, because it is the acidic. That is, when we put blue litmus paper or we insert litmus paper in this solution, because of the hydrogen ion released, or HCl, that is the acidic products, we are going to have our litmus paper turns to red. Hence the solution is acidic. So Roman figure 2 is just that litmus paper turn red from blue to red because hydrogen ions released or HCl acid produced is acidic. Also HClO produces also acidic, hence the solution is acidic. So this is just the equation for the reaction we have in 4C, Roman figure 1. So 4C Roman figure 1 is just asking us to give the equation of reaction between chlorine and water. So we have Cl2, that is chlorine gas, chlorine in gaseous state, react with water, that is H2O. Then we are going to have our products form to be HCl plus HClO. Then we count the number of hydrogen we have here is 2. Then also the number of hydrogen here is 1 and 2. Then we have 2 chlorines also. So the equation has been balanced. So we have HCl and HClO as the product form when we react chlorine with water. Then 4C Roman figure 2. 4C Roman figure 2. Say, why does litmus paper turn red when put in the resulting solution? Why does litmus paper turn red? So litmus paper turn red, turned red. That is, we have blue litmus paper. We have blue litmus paper turns to red. So blue litmus paper turn it to red because the hydrogen ions we have released, or the HCl, that is the hydrogen ion released, or HCl, or hydrochloric acid, which is HCl, acid produced is acidic. Also the HClO, that is one of the product form in 4C Roman figure 1, is also acidic. Hence the solution is acidic. Then we should not forget that the properties of blue litmus paper when insert in acid is that the blue litmus paper is going to turn to red, and that is why we have in the resulting solution in the 4C Roman figure 1, which is HCl and HClO, which is acidic, turn blue litmus paper to red. So this is just the solution to 4C Roman figure 1 and 4C Roman figure 2. If you like this video, click like, then subscribe for more videos. You can still visit our YouTube channels www.educateafricans.com for more videos. Thank you. God bless you. Hello, welcome to Tclassified. Today I'll be answering Waec 2018 chemistry theory, question 4D Roman figure 1. State the trend in boiling point of chlorine, bromine and iodine. You should not forget that from the periodic table we have some properties like electronegativity, like ionization energy, like electrical conductivity. Also we still have boiling point as one of the properties we have in the periodic table. Then boiling point of group 7 elements in the periodic table increases down the group. Then starting from fluorine, chlorine, bromine, iodine and aspartame, we are going to have the boiling point increases down the group. So by studying the trend in the boiling point of chlorine, bromine and iodine, it means iodine will have greater boiling points than bromine and iodine. Then you are going to have bromine having higher boiling point than chlorine. So the trend is going to be that we are going to have iodine greater than bromine, while bromine greater than chlorine. So boiling point increases from iodine to chlorine. So we have boiling point of chlorine and iodine. So we have boiling points. So the trend in the boiling point of chlorine, bromine and iodine. Boiling point of chlorine, bromine, then we have iodine, and iodine we have iodine as explained earlier. We are going to have iodine to be the first one, so greater than bromine, then we are going to have bromine greater than iodine, so the boiling point of iodine will be greater than the boiling point of bromine, while the boiling point of bromine will also greater than the boiling point of iodine. So boiling point increases as given in the above. So boiling point increases from iodine to chlorine, from iodine to chlorine. So here it is iodine greater than bromine, then we have bromine greater than chlorine, so the boiling point increases from iodine to chlorine. So as explained using the periodic table, so we have boiling point increases down the group, then we are going to have iodine having greater boiling point than bromine, then bromine is going to have greater boiling point than chlorine. So this is just the answer to the question 4D Roman figure 1, that we have to state the trend in the boiling points of chlorine, bromine and iodine. If you like this video, click like and subscribe. You can still visit our website www.educateafrican.com, then our YouTube channel jump waec.com for more videos. Thank you. God bless you. Hello and welcome to Tclassified. Today I'll be solving Waec 2018 chemistry theory question 4D Roman figure 2. Explain briefly why water has higher boiling point than ammonia. Explain briefly why water has higher boiling point than ammonia. Water has higher boiling point than ammonia because water has stronger hydrogen bonds than ammonia. There is stronger hydrogen bond between water than ammonia. Then also, oxygen atom has 2 lone pairs of electrons, while nitrogen has only 1 lone pairs of electrons. So it's one of the reasons why water has higher boiling point than ammonia. Then oxygen is more electronegative than nitrogen. That is, the oxygen atom we have in water is more electronegative than nitrogen. So these are the reasons why we have water has higher boiling point than ammonia. That is, there is stronger hydrogen bond between water than ammonia. Then we still have that oxygen atom has 2 lone pairs of electron. That is, the oxygen present in water has 2 lone pairs of electron, while nitrogen has only 1 lone pair of electron. Then we still mention that oxygen is more electronegative. That is, the oxygen present in water is more electronegative than nitrogen. So oxygen is more electronegative than nitrogen. So water has higher boiling points than ammonia because Water has stronger hydrogen bond. Water has stronger hydrogen bond. Hydrogen bond than ammonia. Also, oxygen atom, that is the oxygen atom present in water, the oxygen atom has 2 lone pairs of electron, has 2 lone pairs of electron, 2 lone pairs of electron, while we have nitrogen, and nitrogen, so the nitrogen in ammonia, while the nitrogen atom has 1 pair, just 1 pair of electrons. Also oxygen is more electronegative, than nitrogen. So this is just a brief explanation on that. So we can just say that water has higher boiling point than ammonia because of stronger hydrogen bond, between water than ammonia. So number 2, we can just say that due to lone pairs of electrons, of course here oxygen has 2 lone pairs of electron, while nitrogen has just only lone pairs of electron. Then you can still say that it is due to their electronegativity. So oxygen has higher electronegative than nitrogen, that is oxygen is more electronegative than nitrogen. So this is just a summary of what we used to discuss, what we discussed above. So number 1 and number 2. So that is, we say that water has higher boiling point than ammonia because water has stronger hydrogen bond than ammonia. Also, oxygen atom has 2 lone pairs of electron and nitrogen atom has 1 pairs of electron. Also, oxygen is more electronegative than nitrogen. So we just summarize everything by these 3 sentences: that stronger hydrogen bond between water and ammonia, then due to lone pairs of electron. Then number 3, we have water has higher boiling point than ammonia because of the electronegativity of oxygen and nitrogen. If you like this video, click like and subscribe for more videos. You can still visit our website www.educateafricans.com, then our YouTube channel waecuni.com. Thank you. God bless you. Hello, welcome to Tclassified. Today I'll be answering Waec 2018 chemistry theory question 5a Roman figure 1. State 2 industrial uses of hydrogen. So we have to state 2 industrial uses of hydrogen, but there are so much industrial uses of hydrogen. Like we have number 1, it can be used for filling of weather balloons. Hydrogen can be used in filling weather balloons. Then number 2, we can have as in the manufacture of plastic. So hydrogen is used in the manufacture of plastic. Also, we can see how the manufacture is as in the manufacture of ammonia by ABBA process, that is the production of ammonia. So that is the ABBA process. So we use hydrogen in production of ammonia. It's one of the industrial uses of hydrogen. Then we have in the manufacture of methanol. So it is used in the manufacture of methanol. So don't forget that this methanol is hydrocarbons, then we have the hydrogen combined with carbon. So it is also used in the manufacture of methanol. Then it is also used in oil refinery process or hydrocracking. So hydrogen is also used in oil refinery process or hydrocracking. Then don't forget that this hydrocracking is also the hydrocarbons. So where we have the hydrogen combined with carbon. Then we have the uses of hydrogen to be as in the manufacture of margarine. So we also use hydrogen as in the manufacture of margarine. Then also hydrogen is used as a reducing agent for the production of metals. That is, hydrogen serve as reducing agent of reduction. So when we want to produce metals like copper and lead from their oxides, so that these are the uses of hydrogen. So and it is the industrial uses of hydrogen. Then we have some industrial uses of hydrogen. The number one we can have in the filling of weather balloon. So hydrogen is used in filling of weather balloons. Then number two, we have it as in the manufacture of plastic. Hydrogen is used in the manufacture of plastic. So hydrogen is used in the manufacture of plastic. Then number three, we can also have as in the manufacture. So hydrogen is used in the manufacture of ammonia. So it's used in the manufacture of ammonia. Then don't forget that this manufacture of ammonia is what refers to as ABBA process. It's called ABBA process. ABBA process, that is production of ammonia. Production of ammonia. So ABBA process is production of ammonia. Then we have number four, uses of hydrogen to be as the manufacture of methanol. Manufacture of methanol. And don't forget that this methanol is hydrocarbon, where we have hydrogen combined with carbon. So it's one of the uses of hydrogen as the manufacture of methanol. Then they also uses of hydrogen. So it is also used in the manufacture of margarine. Manufacture of margarine. So hydrogen is also used in the manufacture of margarine. So it's also used in the manufacture of margarine. Then number six, it is also used as reducing agents. So hydrogen is also used as reducing agents. And don't forget that we can define our redox and oxidation in terms of hydrogen inside of hydrogen. So hydrogen is used as reducing agents for production of metals. For production of metals. Then metals like copper and lead. Copper and lead from their oxides. So it is used as a reducing agent to obtain the metals like copper and lead from their oxide. So we still have the uses of hydrogen to be in the oil refinery. It is used in the oil refinery. So hydrogen is also used in the oil refinery process. That is what refers to as hydrocracking. So it is what refers to as hydrocracking. Then don't forget that this is also the hydrocarbons, where we have the hydrogen combined with carbons. So these are the uses of hydrogen. Then we have to state only two, so we can pick out of these listed uses of hydrogen. So we can pick any two of them. So any two of them to answer our question. So as in the states the two industrial uses of hydrogen. So this is just the answer to the question 5A Roman figure 2 that we have to state the industrial uses of hydrogen. If you like this video, click like and subscribe for more videos. Then you can still visit our website www.educateagricans.com for more videos on the solutions to the Waec 2018 chemistry past question or other past questions. Thank you. God bless you. Hello, welcome to Tclassified. So I'll be answering Waec 2018 chemistry theory question 5A Roman figure 2. Then we still have Roman figure 1 there. We have to state two disadvantages of hardness of water. So we have to state two disadvantages of hardness of water. So we have one of the disadvantages of hardness of water is that for washing, hardness of water requires a lot of soap before it can form a lather. Then soft water is ideal for washing as soap lathers readily in it. That's number one. That is, for washing, hardness of water requires a lot of soap before it can form a lather. Then we have number two, hardness of water causes fouring of kettles and boilers. So when we are having hardness of water, it can cause the fouring of kettles and the boilers. Then number three, hardness of water cannot be used in dyeing and tanning as the salt in it interfere with the modes of action of these processes. So it cannot be used in dyeing and tanning. So these are the disadvantages of hardness of water. So we have number one to be. So number one disadvantages of hardness of water is that for washing, hard water requires a lot of soap before it can form a lather. So we have number two, disadvantages of hard water. So hard water causes fouring of kettles. So it can cause fouring of kettles and boilers. So it can cause the bottom of the boiling kettles or boilers. It can cause the fouring. Then number three, hard water cannot be used. Hard water cannot be used in dyeing. So it cannot be used in dyeing and tanning. So hard water cannot be used in dyeing and tanning as the salts, that is the salts present in hard water, as the salts in this are the salts in it interfere with the mode of action, that is the mode of action of dyeing. So the salts in it interfere with the mode of action of this process, that is the process of dyeing. So these are the disadvantages of hardness of water. Then we asked to just mention only two here, so we can just pick any two of the above mentioned disadvantages of hardness of water. If you like this video, click the like button and subscribe for more videos on the past questions and the solution for Waec 2018 chemistry theory You can still visit our website www.educateafricans.com for more videos on chemistry, past questions and solution. Thank you. God bless you. Hello, welcome to Tclassified. Today I will be answering Waec 2018 Chemistry Theory, question 5a, Roman figure 2. Says, consider the equation below. Then we have magnesium hydrogen trioxocarbonate in aqueous form, giving magnesium trioxocarbonate plus water. Then we still have carbon dioxide as a gas evolved. Then we have to state the type of hardness of water being removed as shown by the above equation. We are just asked to state the types of hardness of water being removed by the above equation. But let's see, we have in two types of hardness of water. We have temporary hardness of water, which is caused by the presence of calcium hydrogen trioxocarbonate and can be removed by boiling. So it means temporary hardness of water can be removed by boiling. Then it is caused by calcium hydrogen trioxocarbonate. Then we have permanent hardness as the second type of hardness of water. This is caused by the presence of calcium and magnesium ions. It is caused by the presence of calcium and magnesium ion in the form of soluble tetraoxosulfate 6 and chlorides. Then removal of permanent of hardness. Then we can remove permanent hardness of water by chemicals. So it can only be removed by addition of chemicals, e.g. the chemical like washing soda, which is Na2CO3, sodium trioxocarbonate 4, as one of the chemicals that can be used to remove permanent hardness of water. Then we can still use caustic soda. Then don't forget our caustic soda is sodium hydroxide. So one of the ways of removing permanent hardness of water is still by caustic soda, which is sodium hydroxide. And you can still remove it by zeolite. So we have the two types of hardness of water. Then number one, we have temporary hardness of water as number one. Then number two, we have permanent hardness of water. Then the temporary hardness of water can be removed by boiling. Temporary hardness of water can be removed by boiling. So can remove the temporary hardness of water by boiling. Then the permanent hardness of water, then before we go into permanent, you should don't forget that this temporary hardness of water is caused by, so temporary hardness of water is caused by calcium hydrogen trioxocarbonate. We have calcium hydrogen trioxocarbonate. So it is caused by calcium hydrogen trioxocarbonate and can be removed by boiling. Then we have the permanent hardness of water. Then this is caused in the presence of magnesium and calcium ion. This is caused by the presence of calcium and magnesium ions in the form of soluble tetraoxosulfate 6 and chlorides so it is formed in the presence of calcium and magnesium ion in the form of soluble tetraoxosulfate 6 and chlorides. Then it can be removed, that is the remover of permanent hardness. So it can be removed by adding chemicals. This can be done, the removal can be done by adding chemicals caustic soda, which is sodium hydroxide. Then we can still add a chemical like washing soda. We have washing soda, then that one is sodium trioxocarbonate 4. That is our washing soda. Then we can still have zeolite as one of the chemicals to be added to remove permanent hardness of water. So with this explanation of the temporary and permanent hardness of water, don't forget that we asked for to state the types of hardness of water being removed as shown by the above equation. So with the explanation above, so we can see that temporary hardness of water is being removed using that equation. So the answer to the question is that temporary hardness of water is being removed. So that is our answer. So it is the temporary hardness of water that is being removed as shown in the equation above. So that is the answer to the question asked in 5a Roman figure 2. Then we still have Roman figure 1, which is asked to state that the types of hardness of water being removed as shown by the above equation. If you like this video, click the like button and subscribe for more videos. Then you can still visit our website www.educateafricans.com for more videos on the past questions related to chemistries and the solutions. So thank you, God bless you. Hello, welcome to Tclassified. Today I'll be answering Waec 2018 chemistry theory. Question 5b Roman figure 1 says, in the extraction of aluminium by electrolysis, graphite electrodes are used. State the disadvantages of using this type of electrodes. That is, using graphite as an electrode in electrolysis in the extraction of aluminium, we have to state the disadvantages of using graphite as the electrode. Then don't forget that this graphite is one of the allotropes of carbon. So disadvantages of graphite as electrode in the extraction of aluminium by electrolysis is that at high temperature, oxygen gas produced at the anode reacts with the graphite electrode to form carbon 4 oxide. And don't forget that I mentioned that the graphite is one of the allotropes of carbon, so we have oxygen reacts with this graphite to form carbon 4 oxide. So at high temperature, oxygen gas produced at the anode reacts with the graphite electrodes to form carbon 4 oxide. So we say that at high temperature, that is disadvantages of graphite as electrode. Disadvantages of graphite as electrode in the extraction of aluminium. extraction of aluminium by electrolysis. Is that at high temperature, the oxygen gas produced at the anode reacts with this graphite, Then I've mentioned earlier that this graphite is one of the allotropes of carbon, so react with the graphite electrodes to form carbon 4 oxide, so which is CO2. So this is the disadvantages of using graphite as the electrode, because the oxygen produced at the anode will react with this graphite to form carbon 4 oxide. So if you like this video, click like button and subscribe for more videos on the past questions relating to the chemistry. You can still visit our website www.educateafricans.com for more videos on the solutions to the past questions on chemistries. Thank you. God bless you. Hello, welcome to Tclassified. Today I will be solving question on Waec 2018 chemistry theory. Question 5b, Roman figure 2, says calcium oxide reacts with water to form slaked lime. Then question Roman figure 1, write a balanced equation for this reaction. Roman figure 2, state one of the uses of slaked lime. Then question 5b, Roman figure 2, Roman figure 1, says we should react calcium oxide with water. Then we have CaO reacts with H2O, giving calcium hydroxide, which is CaOH2. Then we have to state the uses of slaked lime. So we have slaked lime uses to treat acidic soil. It is used to treat acidic soil. Then it is also used to make mortar, plastic, or cement. Then it is used in the manufacture of glass. Slaked lime is used in the manufacture of glass. It is also used in the purification of water or removing hardness of water. It is used for the production of bleaching powder. So that's one of the uses of calcium hydroxide. It is used for the production of bleaching powder. Then it is used to test for carbon 4 oxide. So question 5b, Roman figure 1, which we are asked to state or write a balanced chemical equation for the reaction between calcium oxide and water. So we have CaO, that is calcium oxide, reacts with water, giving calcium hydroxide. Then this is what refers to as slaked lime. Then Roman figure 2, we have to state the uses of slaked lime. We have number 1, it is used to treat acidic soil. Then number 2, it is used in the manufacture of glass. Then number 3, it is used in the purification of water. Or removing hardness of water. Or we have it in the removing of hardness of water. removing hardness of water. Then number 4, it is used to test for CO2, test for carbon oxide. It is used to test for carbon oxide. Then it is also used to produce bleaching powder, that is in the production. It is used for the production of bleaching powder. Production of bleaching powder. And number 6, it is used to make, number 6, it is used to make mortar. It is used to make mortar or plastic or cement. Then don't forget that here we were only asked to state one uses of stake lime, so we can choose out of the 6 provided options. That is, number 1, it is used to treat acidic soil. It is used in the manufacture of glass. It is used in the purification of water or removing hardness of water. Then it is used to test for carbon oxide, then production of bleaching powder. It is used to make mortar, plastic or cement. If you like this video, click like and subscribe for more videos. You can still visit our website www.educateafricans.com for more videos. Thank you. God bless you. Hello, welcome to Tclassified. I'll be answering Waec 2018 chemistry theory question 5C, Roman figure 1. What is it meant by saponification? Roman figure 2, list the raw materials needed for the manufacture of soap. Then Roman figure 3, name the byproducts obtained from the manufacture of soap. Now the saponification. Saponification is the alkaline hydrolysis of fats and oil to produce soap and propan 1,2,3-or and the corresponding sodium and potassium salt of the component fatty acid. Then we can add the equation backing up this as fat and oil plus caustic soda giving soaps and propan 1,2,3-triol. Then as for question Roman figure 2, we have to list the raw materials needed for the manufacture of soap. So the raw materials needed are oil or fat, or we have alkaline, as we have it in the definition of saponification and the equation, that is we react alkaline and the fat and oil together to give soaps and propan 1,2,3-triols. Then question Roman figure 3, we have to give the byproduct obtained from the manufacturer. So then the byproduct is propan 1,2,3-ols and the soaps. Then question 5C, Roman figure 1, we have to define saponification. 5C, Roman figure 1, we have to define saponification. So saponification is the alkaline hydrolysis. Of fats or oil to produce soaps and propan 1,2,3-triols. 1,2,3-triols and the corresponding sodium and potassium, and the corresponding sodium and potassium salts of the component fats, that is the fatty acids. So we can add the equation for this as fat or oil reacts with caustic soda. So that is our alkaline mentioned in the definition, that is the caustic soda. And the caustic soda is sodium hydroxide as an alkaline. Then we have it give soaps and propan 1, 2, 3 triols. Then propan 1, 2, 3 triols is given as this. In the structural formula, we have the structural formula to be like this for propan 1, 2, 3. Also, we have hydroxide attached here, we have hydroxy group attached here, then we still have another hydroxy. So we have propan 1, 2, 3 triol. So we have hydroxy group bonded with the first carbon, second carbon, and the third carbon. So we have propan 1, 2, 3 triols when we react fat or oil with caustic soda. So we have soaps and propan 1, 2, 3 triols. Then question Roman figure 2, 5C, Roman figure 2. We have to list the raw materials needed for the manufacture of soap. So as we have it in this equation, we have fat, then we have caustic soda. So these are the raw materials needed for the production of soap, that is the manufacture of. So we have the first one to be fats, or we have oils, then we can still have the alkaline. So these are the two raw materials that is needed to manufacture our soap, as in the saponification. Then we have figure 3. So the byproduct of the saponification is soaps. We have soaps and propan 1, 2, 3 triols. So this is the answer for the question asked in 5C Roman figure 1. That is, we have to define saponification, or what does it mean by saponification. It is just the alkaline hydrolysis of fat and oil to produce soaps and propan 1, 2, 3 triols and the corresponding sodium and potassium salt of the component fatty acid. Then we have the equation as we have fat or oil reacts with caustic soda, which is sodium hydroxide, to give soap and propan 1, 2, 3 triols as the product. Then we give the structural formula of propan 1, 2, 3 oils having hydroxy group attached to the first, second, and the third carbon. Then we have 5C Roman figure 2 asking us to list the raw materials needed for the manufacture of soap. So as we have it in the equation given above, we have fat and oil, then we have alkaline as the raw materials needed. Then Roman figure 3, we have to name the byproduct obtained. Then the byproduct is soaps and the propan 1, 2, 3 triols. So if you like this video, click like and subscribe for more videos. Then for more videos, you can still visit our website www.educateafricans.com. Thank you. God bless you. Hello, welcome to Tclassified. Today I'll be solving question on Waec 2018 chemistry theory. Question 5C Roman figure 1 says, what does it mean by saponification? Then question Roman figure 2, list the raw materials needed for the production of soap. So question Roman figure 1, we have to state what does it mean by saponification. Saponification is the alkaline hydrolysis of fats and oil to produce soap and propan 1, 2, 3 triol. It is the alkaline hydrolysis of fats and oil to produce soap and propan 1,2,3 triose. Then we have to leave the raw materials needed for the manufacture of soap. So the materials needed for the manufacture of soap are oil and fat. Then we have alkaline. So these are the materials needed for the production of soap. Then number one, which we are asked to state what does it mean by saponification. We have C Roman figure 1. Saponification is the alkaline hydrolysis of fats and oils to produce soap and propane 1,2,3 triols. And this is the structural formula for propane 1,2,3 triol. We have 3 hydroxy group bonded with these 3 carbon. So, and these are ready for the hydrogen attachment. So we have propan 1,2,3 propan 1,2,3 triols. So this is answer to question C Roman figure 1. Then Roman figure 2, you have to state the raw materials needed for the manufacture of soap. Then the raw materials needed are, we have oil and fats. Then we have number 2 to be alkaline. So alkaline, as we have it in C Roman figure 1 for the that is saponification. So question C Roman figure 1, saponification is the alkaline hydrolysis of fat and oil to produce soap and propan 1,2,3 triols. Then the structural formula of propan 1,2,3 triol is given. Then we have question C Roman figure 2 that we have to state the raw materials needed for the production of soap. Then it has been listed here as alkaline and oil and fats. For more solutions on questions related to chemistry, past questions, you can visit our website www.educateafricans.com. Then don't forget to click like button and subscribe for more videos. Thank you. God bless you. Hello, welcome to Tclassified.com. I will be answering Waec 2018 chemistry theory question 5D with the aid of a chemical equation. Explain briefly how iron is extracted in the blast furnace using iron ore, coke and limestone as raw materials as the Roman figure 1 bottom of the furnace, Roman figure 2 middle of the furnace, Roman figure 3 top of the furnace. So you have to use equation all through. For Roman figure 1, the oxygen gas in the hot air combined with the carbon, that is coke. So coke is one of the allotropes of carbon to produce carbon 4 oxide, which is reduced to carbon 2 oxide. So this happens at the bottom of the furnace. Then at the middle of the furnace, which is Roman figure 2, the calcium carbonate, that is CaCO3, decomposes under great heat to form carbon 4 oxide, calcium hydroxide, and calcium carbonate decomposes to remove the impurities silicon oxide. Then Roman figure 3, that is at the top of the furnace, iron 3 oxide is reduced to metallic iron, that is we have Fe2O3 plus 3CO to give 2Fe plus 3CO2. Now with this explanation, so we have question 5b Roman figure 1, that is what happened at the bottom of the furnace. So that is what we have for the 5d Roman figure 1. We have to write this, then give our answer in equation. That is, we have the oxygen that is O2. We use O2 to represent the oxygen gas. The oxygen gas in the hot air combines with the carbon, that is coke. Don't forget that coke is one of the allotropes of carbon, to produce carbon 4 oxide, that is CO2, so this carbon 4 oxide is reduced to carbon 2 oxide. So carbon 2 oxide. Then don't forget that here we have to use chemical equation. So we have carbon react with oxygen gas to give carbon 4 oxide gas. Then this carbon 4 oxide gas is reduced, that is CO2 in gaseous states, so it is reduced to form 2CO, that is carbon 2 oxide, as explained above. So with the aid of the equation, so we have C plus O2 giving CO2 gas, then carbon 4 oxide gas reduced to carbon 2 oxide. That is what happened in the bottom of the furnace. Then Roman figure 2, that is at the middle of the furnace, what happens? We have the calcium carbonate, that is CaCO3. The calcium carbonate, then the chemical formula is CaCO3, decomposes. Calcium carbonate decomposes under great heat, to form carbon 4 oxide, and calcium oxide, and calcium carbonate CaCO3 decomposes to remove the impurities, that is silicon oxide, SiO2. Then we have to use equation. We have to represent this expression in equation. Then we have the equation to be, we have calcium hydroxide, the calcium carbonate giving CaO, that is calcium oxide, as mentioned here, calcium oxide. Then we have CO2 produced, so we mentioned that here as well, CO2. Then we have calcium hydroxide plus silicon oxide, SiO2, to give CaSiO3. So this is what happened at the middle of the furnace. But let's see what happened at the top of the furnace. That is Roman figure 3. So iron oxide, iron 3, the iron 3 oxide is reduced, that is at the top of the furnace, is reduced to metallic ions, Then representing this in equation, we have iron 3 oxide, that is Fe2O3 plus 3CO, that is carbon 2 oxide, to give 2Fe. So it is reduced to iron, that is metallic ion. Then we have 3CO2 to balance our equation. So this is what happened at the top of the furnace. So we have represented what happened at the bottom of the furnace, middle of the furnace, and at the top of the furnace with the equation. Then we have, for the first one, we have carbon reacts with oxygen to give carbon 4 oxide. Then we have our carbon 4 oxide later reduced to carbon 2 oxide, as we have it in the equation. We have CO2 plus C giving 2CO in gaseous state. Then at the middle of the furnace, we have the calcium carbonate, that is CaCO3, decomposes under great heat to form carbon 4 oxide and calcium oxide. And this calcium carbonate decomposes to remove the impurities, silicon oxide. Then we represented that one in the equation as we have calcium triiosocarbonate 4 giving calcium hydroxide and calcium and carbon CO2, that is carbon 4 oxide. Then we have calcium oxide react with silicon oxide to give CaSiO3. So that is what happened at the middle of the furnace. Then at the top of the furnace, we have iron 3 oxide reduced to metallic ion, and that is why we have it in the equation. We have Fe2O3, that is iron 3 oxide react with CO, that is carbon 2 oxide, to give metallic ion and CO2. So this is what happened in the bottom, middle of the furnace, and at the top of the furnace. So if you like this video, click like and subscribe for more videos. You can still visit our YouTube channel www.educateafricans.com. Thank you. God bless you.